So the first part of the actual presentation of Aivia 5 starts here. I'll talk initially about neuron analysis. It's an automated method which we have been working on the last 4 or 5 months. After that, I'll pass over to Bryce, who will introduce the immersive image exploration with the help of Hoyen, who will be doing the demonstration. And then it will come back to me to finish up with the classification tool, the cell classification tool at the very end. And then we'll finish up for today. I should say that today we're mostly focusing on what we are doing, what is possible with Aivia 5. We intend to have follow-up webinars and documentation that will show how we are doing things. And we hope that you will join us for those webinars in the future, where we'll show you what algorithms we're using, why we're using those, and what are the benefits. But that's not the focus of today. It's mostly the what. And we did that in this way because there is already a lot to talk about, and we don't want to keep you too long. So for today's scope is mostly about the what do we do. So the Neuron Analysis tool is fully automated, and you can see on the bottom hand side, on the bottom right hand side, what parameters you will need to put in order to get the protocol to run. I'll do a brief demo in a moment, but you can get pretty good tracing with the automated method. For editing, we have introduced something called the dendrite pencil, which allows you to draw very quickly in 3D space and get additional dendrites added to the traces that you already have. And you can also connect those dendrites to the network that you obtained automatically. There are a lot of parameters that we calculate for you, and if there's anything missing, please do let us know. We will work to add those in. Right now there's over 50 different parameters, but as I said, we can add more. The detection itself is very quick. This is one example. It's one of the examples we have on our website as well, and it's on our YouTube page, which I encourage you to follow. We'll be adding more things there. And on the data set with 1,500 pixels by 1,500 pixels by 500 slices, it takes about 25 seconds to run the image analysis protocol. And the results we find are pretty robust, but they're not 100% as with every algorithm. There's always limitations. And so we have added a tool that will, I mentioned already, the dendrite pencil, that will allow you to look at a data set that is already analyzed or semi-analyzed, and then you can add traces. And that's what I'm showing here in this brief video. So you can trace in 2D space, and the software will be measuring the intensity in Z and placing those spheres that you can see in the correct position in Z. And you can do that iteratively to either build a full network by hand, if you choose. There might be reasons for that, or to add traces that are missing on your original result. It is iterative, so you can just keep building, and it will keep adding to the dendrite that you're creating. Now I'll show you this in a moment in the demonstration. In terms of rendering or visualization of the results, we do have 3 modes, which may not be very apparent. This was a video, but unfortunately it's not showing right now. We do have 3 modes. One of them is a surface rendered mode to visualize the dendrites. We have another one which is a point and sphere, and another one which looks like a mesh, so it's transparent and you can see the signal, the original signal, inside of that mesh. Inside the software we also have a way to plot the results. Either it has histograms or scatter plots, and it's fully interactive, so it will connect These dots that you see here are connected to a specific dendrite on the view and to a particular row on the spreadsheet. So with that, I think I'll go to the demo of the Neuron Analysis tool. But before I jump in, just give you a brief intro to the anatomy, or the where things are, because you might want to try it later on yourself. You can download the software from our website. Not yet, but you will later today. And this is what it looks like when it's open. So we have this panel on the bottom, which is a gallery view, also allows you to do some manual measurements and do some edits. Then on the top center, you have the major view, which could be a 2D viewer, a 3D viewer, a gallery view, and even it's also the place where you will see the note indicating that you are in VR. And then on the right hand side, top right hand side, you have the display settings, which will control the volume rendering, but also which detected objects you will show and how you will show them. I already mentioned for dendrites we have these three modes: the spheres, the surface rendering, and the mesh. That's also controlled here, as well as the colors of each object, the color coding. And on the bottom right is where you set up all the analysis protocols, and where you can also create the charts. Okay, so I will jump into Aivia. All right, hopefully you will be able to see it. It's in the mode very much the same as what you saw in the PowerPoint a moment ago. This panel on the bottom is collapsible, as is the one on the right hand side. And that's very useful when you already have the results and you want to explore them on your flat screen. So you have more space to look at the results. That's why we have it this way, so you can collapse everything. As I mentioned, Aivia has a large number of protocols, and you can see them all here. These are all the ones that we have created. So we have many things from cell counting all the way to wound healing. But the one we're talking about today, and the one we've been developing over the last few months, is this one for 3D neuron analysis. So a data set like this is the one I mentioned earlier. We would need to set up some parameters, so the soma diameter, the dendrite diameter, the dendrite length in terms of the smallest branch you are likely to find, its intensity, and a mean offset. So those parameters, I will explain them in another webinar, in another occasion, so we have more time to discuss them in detail. But for today, we have it already set up in a way that is going to produce reasonable results. So I just started it now, and on a data set like this, if your computer is doing just this, it will take something like 25 seconds. Today, it's likely that it's going to take around 40 to 45 seconds, because we have many things hooked up to this computer right now. There's 2 webcams, we're streaming live, and so it's a little bit more resource deprived right now. So I don't know if there's any question I could answer right now. Is there anything?
Currently not any questions.
Nothing? Okay, good. So the rendering has, so the analysis has been completed, and now the rendering is happening, and it's already completed as well. So we can already start to explore the results. So let me show you. So that's the original or volume rendered image. And if I turn on the analysis that we've just completed, you can see it here. I'm going to change the coloring so that you can see the segments in different colors. And you can see now the segments here in different colors. Yeah, so that's what we would do to get the analysis done. Now, you will see that not everything is ideal. And so we can edit it, and I just wanted to show you that you can also you can see the parameters here. So these are the measurements for for this data set. And if you select particular segments or particular dendrites, it will highlight them in the view. You can see it just highlighted that one on the top. If I select a different one, it selects a different one. If I select that one, it selects that one. So it's basically connected up here. If I had a data set like this and I wanted to do some editing, we can go into this mode here called Neuron Editor, and you can select the pencil, dendrite pencil, can determine which diameter you want to draw at. I'm going to set it to 2.5, and then you can just simply draw. This is obviously too large, so I can just go back, set it a little smaller, and do it again. It's still too large. Maybe 1.2 is good. So I can draw like this, and this is drawn that segment in 3D space, and it ignored all that background that you see at the back of the image. You can draw a few other segments here, one here, here. Just going to draw all of these. Okay, and then I can connect them up simply using the connect button here. These are already connected. And that would be how you do dendrite editing. You can do this as long as you want. You can also draw from scratch. You already have a soma here, so you can start to draw from the soma out and build your own network. If you still have something, so I noticed there's still something still missing here, I can just draw the rest and connect these two, and now they are connected. So these are now connected. They are part of the same network, and that's how you do the editing. You can also, if you see something wrong, let's imagine that there is something wrong here, you can delete a point. Just simply select the delete, select the point, hit delete, and it's now two separate segments. One over here and one over here. You can also connect segments that are not. That's what I was doing earlier. So you can just click, drag, and drop, and then it's one single segment. So I think that's it in terms of the demonstration for the neuron detection and the neuron editing.